Hi and Assalamualaikum. We are from Group 6. We will present about our assignment group for multivariable calculus. So our group members are Edina Nur Nadira, Muhammad Alif Suhairi, Nur Aziza Atira, and lastly, which is me, Shafia Ain. So for our assignment group, we were assigned to do the question number 6, which is for group 6, which is to solve the following problem by applying the chain rule. So before going to manual calculation, I will present about the introduction of the chain rule. The chain rule approach is one of the subtopic in partial derivative subtopic, which is very useful technique in calculus, particularly when working with composite function or function with several variables. So the general formula for chain rule, if z is equal to fxy is a differential function of x and y, are both differential to t, it can be expressed as below. This rule serves as a compass for traversing the linked terrain of function, allowing for the investigation of gradient, rate of change, and the stable interplay of variable in varied real-time system.
Hello, my name is Muhammad Alif Zuhairi bin Arifins. I, representing my group, which is group 6, will explain our manual calculation for the question given, which is this question 6 for our group. Okay, we need to solve these questions by applying chain rule. Okay, so the first step that we do is first we create three diagrams based on the three equation given, which is equation z, equation x, and equation y. So the first one, we look at the first equation, which is equation z. From the equation z, from the variable z, we got another two variable, which is variable x, another two variable, which is variable x, and variable y. So from the T diagram, z, we need to split it to two, which is x and y. And then from the equation x, which is variable x, we got another two variable, which is variable u, and variable v. So we split from the equation x, we split to 2. And then also same goes to equation y, variable y. From variable y, we got one variable, which is variable v. So our tree diagram will look like this. Okay, the question asks to find partial derivative z to the respect of u and partial derivative z to the respect of v. So from the tree diagram that we have done, we can find partial derivative z to the respect of u and partial derivative z to the respect of v. How? Okay, so for the first one is partial derivative z to the respect of u. We look at our tree diagram. Where can we see z and u? So we can look see we have z here and also we have u here. So the partial derivative z to the respect of u is we have to differentiate z to the respect of x times differentiate x to the respect of u. That's for our first partial derivative, which is partial derivative z to the respect of u. So for the second one is partial derivative z to the respect of v. We have to look at our tree diagram where have z and v. So z we have here and v we have 2, which is from the variable x and from the variable y. So what we need to do is the first one, we look z to the v here. We need to differentiate z to the respect of x first, and then the second one is we times differentiate x to the respect of v here, and then we need to differentiate z to the respect of y and times differentiate y to the respect of v. So we will get our equation for partial derivative z to the respect of v like this. Okay, after we have done finding the partial derivative for z to the respect of u and z to the respect of v, we can go for the next step, which is find each of the differentiates that we need. So the first differentiate that we need is z to the respect of x. So the answer that we get is 2x divided by x squared minus 2y. And then for the second and third one is actually the same. As you can see, for the variable x, the equation for variable x equals to u plus v. U and v is the variable for u plus, and v is only 1. So when we differentiate x to the respect of v and x to the respect of u, each will get 1. So the first one is differentiate z to the respect of y, we'll get minus 2 divided by x square minus 2y. And then for the last one, differentiate y to the respect of v, we will get e to the square of v. Then we already get all the answer for each differentiate. Then we can replace it at the equation and we'll get the final answer.
Hi and Assalamualaikum. My name is Nur Aliza Atiyah binti Abdul Aziz and my metric number is BE20303. So today I'm going to explain on how we can get the final answer for dz over du and dz over dv. As my friend has been explained before, we can find the dz over du and dz over dv by applying this tree diagram, which we can make it more easier. And from the tree diagram, you can get dz over du equal to dz over dx multiplied by dx over du. Meanwhile, for dz over dv is equal to dz over dx multiplied by dx over dv plus dz over dy multiplied by dy over dv. As we can see here, this is all the calculation that we needed to do the differentiation from the equation here. From tree diagram, dz over du is dz over dx multiplied by dx over du, and we can see from the calculation before, which is dz over dx is 2x over x squared minus 2y multiplied by 1, which is dx over du, and we got the answer here is 2x over x squared minus 2y. Once we got the answer, we need to insert the original form of x and y, which is x is equal to u plus v and y is equal to exponent of v. Once we have inserted the original form x and y, we can get here is 2 multiplied by u plus v over u plus v squared minus 2 exponent of v. For dz over dv, the equation is dz over dx multiplied by dx over dv plus by dz over dy multiplied by dy over dv. Okay, so dz over dx multiplied dx over dv is just like the previous one, which is we have here 2x over x squared minus 2y multiplied by 1 plus dz over dy, which is negative 2 over x squared plus 2y multiplied by dy over dv, which is exponent of v. The final answer should be 2x minus 2 exponent of v over x squared minus 2y. Once we have already got the final answer for the differentiation, we can put the original form of x and y, which is we got 2 multiplied by u plus v minus 2 exponent of v over u plus v squared minus 2 exponent of v. And that would be the answer for both dz over du and dz over dv. And that is all from me. Thank you.
Next, for the coding script, we are using MATLAB application to determine the answer for the problem number 6. So first, we declare the function that we use in the problem. So the given function z, which is z equal to ln x squared minus 2y, and then we find the derivative of dz dx and dz dy with respect to u and v. Next, we write down for the equation of x and y. Then we differentiate the function x respect to u and v, and then equation y respect to v. So to get the answer for dz du, we use the same formula as in manual calculation, which is dz dx need to be multiple dz du, and then same as dz dv, which is dz dx need to be multiple by dx dv, and then plus dz dy multiple by dy dv. As we get the answer for dz du and dz dv, we need to substitute function of x and y into function z to get the final answer. So we first write down the substitution of x and y. So the display result is negative 2u plus v divided by 2 exponent v minus u plus v squared. And then the display for dz/dv, which is 2 exponent v over 2 exponent minus u plus v squared minus 2uv over 2 exponent minus 2 plus v squared.
Assalamualaikum warahmatullahi wabarakatuh. My name is Edina Nadira bin Zanzani. Nama matrix BEE20303. Now, after my teammate have explained about all the coding, and after we have insert all the functions for x, y, and z, so I will explain about the result, and we run it by the section. So the result will end for dz/du 2u plus v over 2 exponent v minus u plus v squared. And after we simplify for dz/du, the answer is still the same. And next for dz/dv, for numerator 2 exponent v over 2 exponent v minus u plus v squared minus 2u plus v over 2 exponent v minus u plus v squared. And after we simplify the answer for dz/dv, we gather up the numerator 2u plus 2v minus 2 exponent v over 2uv minus 2 exponent v plus u squared plus v squared. So that's for the result for MATLAB simulation. So now I'm gonna make a comparison between manual calculation and MATLAB simulation. So this is the MATLAB simulation answer. So first one, for dz/du, this is the answer. 2u plus v over u plus v squared negative 2 exponent v. And for the MATLAB simulation, this is the answer. So I'm gonna explain a little bit about the MATLAB simulation answer. In MATLAB simulation answer, the negative sign is not removed, so I have multiplied with negative sign to get more beautiful answer. So this is the final answer for MATLAB simulation. And MATLAB simulation and the answer for MATLAB simulation and manual calculation is aligned with each other after we compare it. Second one is dz for dz/dv. Manual calculation answer is 2u plus v negative 2 exponent v over u plus v squared negative 2 exponent v. And for MATLAB simulation answer, this one I have explained about it. For the answer, I multiply with negative sign 2, and then all the signs have changed. And then for the final answer for MATLAB simulation, after we rearrange it, positive sign in front and negative sign is at the back. This is the final answer. And after we compare the MATLAB simulation answer with manual calculation answer, is aligned with each other. So in conclusion, manual calculation answer and MATLAB simulation answer is aligned with each other. That's all from me. Thank you.